You might be wondering, what do the gauges or logging parameters mean for Kia K5 GT Line 1.6 Turbo owners? We're going to look at the terms, definitions, and concepts required to be able to understand the JB4 and the logs. I'm assuming you bought a Kia because you're not a mechanic and you don't want to spend all your time fixing and repairing your cars. So with that in mind, I'm just going to kind of go over the 4-stroke cycle, start there, and then move into the turbo, and then we'll move into the terms and definitions because they're not going to make sense unless you understand how your engine works. So the first step is the intake, and that's when the piston goes down as the crankshaft moves it down to open the intake valve, allowing the air and fuel to enter the cylinder. Then the next step is compression as the piston moves up again to compress the air and the fuel. After that is combustion, and that's when the engine sparks the spark plug, causing the fuel to explode and move the piston back down. And that's followed by exhaust as the piston moves back up to open the exhaust valve and allowing the exhaust fumes to exit the tailpipe. Now, turbocharged engines add to the complexity. I recommend that you watch Engineering Explains video in the description for a 3-minute basic overview that will make understanding JB4 gauges and parameters easier for you. I will kind of just go over this diagram because I found it very helpful. I'm an artist, not a mechanic, so that's why I prefer to see things to help me understand them. So you'll see on the left side, there's the cold side of the turbo, and on the right side is the hot side of the turbo. And that long gray piece in the center is basically the turbo shaft holding both of those together. So normally you'll see just, it'll look like a snail shell, if you will, with both the hot and cold side pushed together in real life. But the purposes of understanding the system, the artist separated those two so you can help understand it better. So start with the red side of the turbo where the turbine is marked in green. And basically the exhaust is what begins to power the turbo and cause it to spin to begin to cause the compressor to bring in the air and compress it. So you can see the air filter, then it runs through the mass airflow sensor, and then it goes into the boost pipe. And then there's a blow-off valve shown there that usually will, on our cars, will recycle it back into our intake side of the turbo, unless you add a blow-off valve spacer that lets it go off into the air. So following the boost pipe, it'll go through the intercooler that's being cooled as your car's moving forward. It looks like a radiator. Then from there, it goes into the charge pipe and then into your throttle. The throttle is not to be confused with your pedal, but we have a throttle and a throttle body, and that air moves into the intake manifold, and then it goes into the cylinder. In between the intake manifold and exhaust manifold in this drawing, at the top of the cylinder in the inline 4 that we have in the GT line will be your coil packs and your spark plugs right in the center there. And then it'll flow out of the exhaust manifold back up towards the wastegate, which you see on the right hand side, that either allows air to go straight back into the turbine to continue to allow it to spool up, or bypass it through the bypass duct. And then from outside of the turbine, that arrow to the right of that red area, you see the dump pipe, which everybody just calls it the down pipe. And on your downpipe is where your primary catalytic converter is and your O2 sensors. And from there, it moves into your mid pipe on the K5s and then into the catback, which includes your muffler on these systems. Then in the center of the screen, you can see the boost controller that bleeds boost signal to control the wastegate. And you can see how that's controlling both the wastegate and the blow-off valve. And you can kind of see this whole system is very complex. And that's why a lot of the parameters that you're going to look at on the JB4 screen, and also later on when you actually start reading your logs, all these parts and areas are very important. And to help you out, I kind of highlighted the areas that you are going to hear about and see as we explain each of the parameters. Okay, so I'm getting all my information primarily off of JB4 Tech, the Kia Hyundai Turbo discussion forums. And I did borrow some information from the Beamer forums on JB4 Tech. So this is your primary resource. You can just kind of go through here and scroll through, and then you'll see down here there's logging parameters, and that's where we're getting the parameter information. And so here it is. Here's where all this stuff's coming from. I'm just going to talk about it and show you images to make all this make sense, because some people are not verbal learners, they're visual. So I'm going to show you a different way. So just like we were talking about before, turbos affect all four strokes: intake, compression, combustion, exhaust. And so I've arranged all the parameters in that same order, beginning with the intake. And so that's how we want to kind of go through this, just so you can kind of follow along. First, I want to explain there are 4 different fail-safes built into JB4. There's boost, AFR, fuel pressure, and fuel trims. And we'll go over those as we're going through the different components. These fail-safes are built in to prevent damage to the different turbo components and your engine. Let's begin with turbo intake parameters. So boost measures pressure in front of the throttle body in PSI. And the normal factory range is about 12 to 14, depending on the barometric pressure, intake temps, engine speed, time under boost, and other. Depending on which map you're running, it'll be normal to see your boost between 16 and 20 PSI. If your boost exceeds the boost safety setting on the user adjustment page, it'll disable. So it's interesting, as I was reading about this, it says, remember, with this platform, boost targeting is load-based, which means at lower elevation, colder temperatures, you will have lower boost target than higher elevation, warmer temperatures. So this is important. Like me, I live in the desert, so I was always wondering, how does JB4 deal with my high elevation desert climate? So all this is here to make sure and try to ensure that the car performs in a similar way based off of whatever driving conditions you're in. It's interesting to note that if you double tap on the gauge, it'll show max boost. And that's important. So if you're driving along and you shouldn't be driving staring at your gauges, that's dangerous. But you can double click and kind of see what your max boost was as you were had wide open throttle or whatever you're doing. I just wanted to point out is boost is one of those critical items. Okay, so boost 2, as you can see here, is the pressure behind the throttle body in the intake manifold. And it says that this is generally a better indication of how much boost the engine is actually under. And it says normally boost 2 will mirror boost unless the throttle blade is closing enough to limit manifold boost. And so same thing here, you can double tap to show the max boost. I personally run boost 2 after I read this, and it kind of just gives me a better understanding. That way you're not getting weird false positives by seeing a spike that looks like it went crazy, it went over. Next is target. This is how much boost over factory the JB4 is requesting. And it varies by map, etc., etc. But what it's trying to say is that in general, map 2 will run about 6 psi over factory, peak tapering down to 4 psi over factory at higher engine speed. I think in the current version, I think it's 5, and it'll taper down, of course, probably about 3 or so after that. Next is ECU PSI. The ECU, or engine control unit, is just another name for the engine computer. This is how much boost the ECU is observing and will generally mirror factory boost levels. And PSI is pounds per square inch. Next is your DME BT. The DME, which stands for Digital Motor Electronics, is also just another name for the engine computer. DME Boost Target, that's what the BT stands for. And this represents how much boost the ECU is requesting at a given moment, but is not enabled on the Kia platform yet. Now, I do see the DME BT actually coming out on the logs and stuff, but it's just to let you know what it is. OU target. This stands for the overboost, underboost target. It's not documented, but it always works. And I see this as more of a variable that they're probably using in the JB4. A variable is just something that kind of holds, it's a element that holds different numbers that can change. That way, in the computer software that JB4 is using, they can use it to run calculations and everything like that. Almost all of these are, well, all these are variables, but some of them are read-only variables, and some of them are read-write variables that JB4 is changing. So you're getting like a full set of information in your Kia. Now let's talk about turbo exhaust. As you can see here, if you look where the exhaust manifold is in the image, and then you'll see the wastegate to the right of that in the picture. The parameter that we're looking at is WGDC, and this stands for wastegate duty cycle, but it's technically the JB4's wastegate duty offset as a wastegate control. So turbo wastegates are placed on the exhaust side of the turbo system and are used to control turbo speed. Turbo blow-off valves are placed on the boost side and are used to vent boost into the intake tube once you let off the gas pedal. And that's that psst sound that you hear. So in general, this wastegate duty cycle is the percentage that measures how much the wastegate solenoid is actuated, and it controls the amount of boost pressure in a turbo system. A 0% wastegate duty cycle means it's fully closed, forcing the turbo to run on mechanical boost pressure. 100% wastegate duty cycle means the solenoid is fully open, forcing the turbo to run on maximum boost pressure. And it says if it's not equipped with EWG connectors, this parameter has no meaning. Values above 50 are closing the wastegate more, and values below 50 are opening the wastegate more. And exactly 50 is a complete pass-through with no changes. The next parameter is load. And according to the JB4 Beamer forum, this represents the DME's load index, in other words, the engine load, and is very useful when working on back-end flash mapping to identify where within a flash map table a tuning change is being made. So again, this isn't something that you'll be using, but it's just for your understanding on these parameters or helping our tuners understand things, but this is just for your information. FF stands for feed forward. It's a component of an optional EWG PID control system. PID stands for Proportional Integral Derivative Controller. Basically, that adjusts the engine's power output to restore the vehicle to its desired speed. So in general, the feed forward value represents a disturbance fed into the PID instruction before disturbance has a chance to change the process variable. Feed forward is often used to control processes with a transportation lag. Concerning the JB4, adjusted via the feed forward and duty bias user adjustment settings, the PID output is added in to arrive at the final wastegate duty cycle. So you can see all these that we just went over are all kind of helping each other out, and they're all indicative. Like load is also dealing with the boost, but feed forward is dealing with the wastegate duty cycle. So you can kind of see that all these things are grouped together accordingly to kind of help you understand along with the graphic or the diagram that is on the screen. Now let's look at the human element and the computer response. Pedal. That is how far down the gas pedal is being pushed from 0 to 100%. Note, while using cruise control, this value will always report 0. So your pedal is what you're doing to the JB4 and it's recording it. Throttle, which is the next element, is the position of the throttle body, and this value is run by the ECU. And they say it's important to realize that the throttle body itself is very oversized, meaning that there needs to be significant throttle movement before you'll see any deviation between boost and boost 2. The ECU generally uses throttle to regulate ECU PSI to DME BT, closing throttle when ECU PSI exceeds the DME BT. And they have a special note for everybody that's modding their exhaust systems. Like I know I have basically a wide open catback. So they say on cars with fully modded exhaust systems, you might see boost creep over target in higher gears. And when that happens, you'll see the throttle close proportionally to maintain boost 2 on target. So that's good to know if you ever see anything. You have to consider your exhaust, especially if you're gonna try to replace your downpipes. It's any kind of modification, you're gonna see a change, and the JB4 begins to adapt for that. The next one is the RPM, which is your engine speed, and this is more important for manual transmission cars. Speed is the road speed in miles per hour. GPS speed uses the GPS position to calculate speed. Now let's talk about the compression cycle, fuel and air. The first parameter is TIAT, which is your intake air temperature. And this is measured in the charge pipe just before the throttle valve and can be thought of as intake manifold temperature. And this number is used to detect heat soaking, also to prevent damage. And so this is a critical parameter, and I always have this one running inside my JB4 mobile app. Next is AFR, and that's your air-fuel ratio. This is another critical parameter. And this is the second failsafe. If AFR goes leaner than 14:1 at higher RPM, the JB4 will disable. Again, this is another way that it's protecting your engine and kind of show how the engineers are doing their best to protect your engine. That kind of makes me feel a little more comfortable about using it. Trims are adjustments made to the fuel mix, plus or minus, in order to balance the air-fuel ratio. And it says the JB4 has scaled fuel trims for quick viewing. 25 in JB4 logs equals 0%, 50 equals 34%, and 0 equals negative 34%. It says generally fuel trims will jump up into the 40s under peak torque and drop down towards 25 at higher RPM. Calc TQ, it says it's a dynamic O2 sensor offset required to maintain a 11.9:1 air-fuel ratio at full throttle. And it's managed by the JB4 internally using its dynamic double fuel control PID. So again, this isn't something that you have to memorize, but it's just what it is. So now let's move into combustion cycle. Ignition 1 through 6. These are a critical thing to watch, and I always leave them on my JB4 mobile display. So the ignition has to do with your timing advance and the specific cylinder, and we only have 4 cylinders. This is useful for knock detection and a graph to prevent damage to the engine. Generally, all cylinders will agree, but as you start to approach a limit of boost for a given fuel quality or octane level, Then you'll start to see a 3.5 degree timing drops in specific cylinders. The lower the grade fuel, the more frequently you'll see these drops. And if you see these drops in the same cylinder repeating several times in a single gear, then it's usually an indicator that you're better off with the lower target for the given fuel. In other words, go down a map. It says, note that timing in all cylinders regularly drops negative during shifts and under some other driving conditions. It says, also note cylinder 1 is sampled via the OBD2, while cylinders 2 through 6 are sampled via RAM read. So there will be some timing differences between the readings due to the different protocols. The next one is ignition average. This is not enabled for the Kia platform yet. Average ignition retard is what it stands for. When I'm looking at mine, I do see it putting out numbers. So maybe it was at the time, I think this was 2019 when the documentation was written. Maybe it wasn't enabled, but they've continued to do upgrades and everything. But again, it's not something that I run on my display, but it's just so you know what it is. Map is the currently selected map. And I see most people run the map gauge on their screen just so they're just reminded on what map they're running. Map 0 is JB4 disabled. Map 1 is 2.5 PSI running 91 octane or above. Map 2 is 4 PSI running 93 octane or above. Map 3 is plus 5 PSI running 93 or any kind of variation up to E30, so any of your blends. Map 4 requires E30 or above. Map 6 is for custom tuning, so if you're running meth or any kind of CPI injection, things like that, that's when you'll mess with custom tuning, but most of us will never mess with that. And Map 7 is specifically for the meth injection usage. Clock, this is used for internal communication diagnostics and generally represents how many samples per second of a CAN bus data are being returned from the ECU. You don't need to know this, but again, it's a variable that's in your system that the tuners are using to kind of make sure that the JB4 is communicating as it should. Now there are some special use gauges and parameters. The first of which is E85. This is your ethanol mixture. And for this to work, you have to have the Fuel-It Flex Fuel sensor. And I think it runs like $480 or $500 for the whole kit. So that's the way if you're running mix or E85 mix or blends, this is the best and the safest thing for you to have. That way you know exactly what's running through your engine and you're not depending on a website calculator to figure out, or worse yet, your own mathematics trying to figure out how much E85 mixture is in your tank. The next one is FPH. That is your fuel pressure, your high fuel pressure. And this is measured in the M-bar of the high pressure pump. Generally, it'll sit above 10. Again, this does not work unless you have the Fuel-It sensor. But once you have that, that will be a critical thing to watch if it's available. Again, if you're under a high boost and you're trying to really push your car, I've seen with the different inline, the Elantra users and stuff, they have to install a different fuel pump. They'll actually bring in the fuel pump from the Sonata, which is the same fuel pump we use for our K5s, to get enough high pressure in there. And I have to verify that it's the Sonata 1.6 or is it the 2.0 Sonata that they're getting. But anyways, long story short is if you have high pressure fuel drops, that means you're not able to deliver enough fuel for the amount of boost that you're running in your car. This is the third failsafe that it has. So if the high fuel pressure drops below 7, the JB4 will disable. The third parameter is meth. And if you have a WMI kit, This will represent your meth flow from 0 to 100%. Now this is methanol, not meth, if you're from the Midwest. Just joking. Now there's some parameters that are not currently used, at least in my testing of all the gauges. The first is AFR2, which is your air-fuel ratio. But again, it's for bank 2. Since we're only running 4 cylinders, we only use one bank. So most of all of these that are not currently used have to do with using another bank that we don't use, or have to do with BMW vehicles. So the next one is can flap, and this is a smart exhaust valve controller for BMW vehicles that uses the steering wheel controls to operate the exhaust flap. So again, that doesn't matter, or doesn't affect us as Kia users. The next one is fuel EN, and this is not used because ours is showing it on the Calc TQ instead. So again, this is that dynamic O2 sensor. The next one is FPL, which is the fuel pressure low, and that's not currently enabled for Kia via the CAN bus, but some people have linked this up to fuel it low pressure sensors they've added on. Gear is your currently selected gear. However, when I tested, there's a alpha version of the mobile that you can download and test to kind of see how that works. And gear does work on that. The next is G-force. It says in the instructions inside the Apple Store that it must be calibrated first. It must be mounted upright, portrait only. You have to select the G-force gauge on the display screen. And then when the vehicle is at a complete stop on a flat surface, you have to double tap it on the G-force gauge. And then when the dot is centered in the circle with the car at a flat rest, you'll know it is calibrated. So when I tested this, it didn't work. So I'm thinking this might be for the N and the inline cars that have they have the G-force in their entertainment center. But just let you know what it is. The next one is T oil. And this is critical if it's available. Basically all these the temperatures are critical if they're available. And at the time of this video, it's not available in the beta, but it is available in the alpha. So the oil, of course, is your oil temperature. Now, why is that important? Because the turbo requires oil for lubrication in order to prevent damage. This also tells you when you can go ahead and boost the car, because you don't want to boost your car with cold oil in it. You'll mess things up. So again, this will be a critical gauge to have always showing because your oil and water temperature are about 15 degrees off or 20 degrees off. And so even though your water might be warm enough to boost, but your oil is still cool. So go ahead and put that sensor on as soon as you can. The next is T water, and that's going to be your engine water temperature, which is already on our dashboard anyway, so not really needed. The next is critical if available, and that's your T trans, which is your transmission oil temperature. And that's something that you want to watch, and it helps prevent transmission slip and damage to your transmission. I've seen people in high boost situations. I'm watching other YouTube videos, they're getting trans slips. And I think the DCTs on the Elantra inline users and stuff like that, they're getting slips as well. It might be an inline that's getting slipped, but anyways, I've seen people getting slipped as they're increasing boost. And the final one is trim 2, and that's your fuel trims in bank 2. And so we really don't use that. And this is your 4th failsafe, because the JB4 will disable if any trim and trim 2 have more than a 15-point variation. So here's all the gauges and parameters coming soon. They're currently in the alpha version. Just wanted to put them all on one screen to kind of make it easy. So this tells me that Burger Motorsports is continually investing in software development and improvement to continue to keep up with changes and fixes, and that's important to me as a customer, artist that has a background in software development myself. So my top 6 gauges to know and display for your Kia K5 GT line are Boost 2, Intake Air Temperature, Air Fuel Ratio, Ignition 1, Trims, and MAP. And once they're available, replace oil temp for trims. So hopefully you found this video helpful. I know most people hate reading manuals. So hopefully this video will do that for you. Just hearing it, seeing it, learning it a different way. This I would consider JB4 basic training. Again, I'm trying to reach you where you're at and explain things in a way you understand and try to save you some time. You can listen to this on the way to work and then have like a basic understanding of all the elements. Do not look at the screen, of course, on the way to work. But again, I have both modes for people to learn how they want to learn, and hopefully this is helpful. And then I'll do the how to read your JB4 logs in a different video. Again, you're part of the learning process as I'm learning this, and I'm sharing what I'm learning with you in real time.